Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry, and this is the lecture number 22 for IR spectra, okay, in which I will explain you the factors affecting peak intensity. Remember that these factors are affecting peak intensity. So with reference to peak intensity, there are three types of peaks or bands in IR spectra. They are known as strong, medium, and weak. Okay. For strong we use S, for medium we use M, and for weak we use W. Normally when absorption of radiation is greater than 80% or 70% rather, then we can say that it is a strong peak. When absorption of radiation is nearly 50%, then we can say that it is a medium band. And if absorption of radiation is nearly 20%, then it is called a weak band. So with reference to intensity, there are three types of bands: strong, medium, and weak. Now we will see factors affecting intensity. The first factor is dipole moment. That is mu. Mu is equal to E into R. E is the charge and R is the distance. Okay. So let us discuss these two fundamental vibrations of C double bond O and of C double bond C. Okay. Here the electronegativity difference of carbon and oxygen will be more, and therefore dipole moment of this group will be more. Therefore, C double bond O stretching frequency will be having higher value. Okay, that is between 1760 to 1650 centimeter inverse because of the higher dipole moment. And here, if you take C double bond C, then mu will be comparatively less. Why? Because both are carbons, and because of asymmetry of the molecule, you will find dipole moment, and that is why here the C double bond C stretching frequency will be appearing around 1680 to 1610 centimeter inverse. So these two stretchings may appear nearly the same similar frequency range, but here dipole moment of C double bond O is higher, and therefore this bond will this band will be strong, while C double bond C stretching gives medium band. So here we can say that dipole moment is directly proportional to intensity. Okay, so that means if intensity increases, dipole moment increases. If intensity decreases, dipole moment decreases. Okay, even mu is directly proportional to E, and mu is directly proportional to R also. So we can say that E is directly proportional to intensity, R is also directly proportional to intensity. And therefore we can have a strong band or medium band depending on dipole moment. Another example is OH, NH, and CH. Here dipole moment will be highest maximum among these three, and therefore it will give you strong band. Dipole moment of this is moderate, little less, and therefore it gives you medium band. And dipole moment of CH bond is comparatively less, and therefore it gives you a little lower medium wave or lower medium or maybe weak band. Okay, so this is the reason why we are getting different kind of intensity of the molecules. Okay, remember asymmetric stretching always brings higher dipole moment, and in that case intensity will be increasing. So asymmetric is always having higher intensity than the lower. Sorry for the interruption, but as we see asymmetric stretching mu will be high and therefore intensity will be more comparatively with symmetric stretching. Now next factor is symmetric stretching. In case of symmetric stretching, you know there are two types of symmetric stretching. One is compression, another is expansion. For example, this is the molecule. One atom is positive, another is partially negative, and suppose electric field may be in this direction, then due to symmetric stretching, compression takes place over here because both atoms approach each other. So in this case, distance decreases, therefore dipole moment decreases, therefore intensity decreases. So here, if molecule shows symmetric stretching but symmetric stretching in compression, then here we will see that intensity will be comparatively less. Now another kind of electric stretching, this is electric field. I'm showing with arrow, and if this is a kind of symmetric stretching where both atoms move away from each other, the electric field will be in opposite direction in this case, like this, then expansion takes place. Due to expansion, atoms move away from each other, therefore distance increases, so that dipole moment increases, and in that case intensity also increases. Okay, so this is another factor which affect the intensity of any fundamental vibrations. Okay, the next one is electronegativity. The third factor is electronegativity. Here, in this case, we will see that OH bond, NH bond, and CH bond. Oxygen is having higher electronegativity than nitrogen. Electronegativity of, that oxygen is greater than hydrogen is greater than carbon. Therefore, electronegativity difference will be maximum in OH. So if you go from OH to CH, electronegativity decreases, electronegativity difference also decreases, and so that intensity decreases. So here we can say that electronegativity is directly proportional to intensity. Okay. The next factor is number of similar bonds. responsible for absorption. Okay, let us take two different examples, like normal hexyl chloride and another is methyl chloride. In case of normal hexyl chloride, this is the structure. There are 6 carbon in straight chain and halogen will be at the end. Here we have only 1 carbon. So here it is clear that number of CH bonds will be maximum. And here number of CH bonds are minimum. Okay, so obviously CH stretching will be giving strong band over here, while in this case you may get medium or weak band. Okay, so this is also very important, that how many number of bonds of the similar type of present. In that case we can say that if number of bonds are increasing, then intensity also increases. Okay, next is concentration of a sample. Of course we need a dilute solutions in all cases, but still we have to find out at which concentration we are getting maximum intensity. Okay, and if at particular concentration if band intensity is maximum, that concentration is known as concentration or to the mark or required concentration. If diluted solution is used with reference to this, then the intensity of the same band decreases. So here if you take very diluted solution, then intensity will be very low. Of course dilution required is very less comparatively in case of infrared spectra, but still this is also one of the factor. Next factor is Fermi resonance. We have already discussed what is Fermi resonance. Remember that if fundamental peak is having small, then overtone peak will be having higher intensity. Okay, so this way then you will have a fundamental peak with a medium, then overtone peak will be strong. So it is like that. Okay, so these are the factors which affects intensity of IR bands. That's it in this lecture. Thank you so much.